So, hi team, we are presenting this presentation for a group project which was about distributed billing system. So, my name is Bhavesh, and we all will describe what we did for this particular project, what our contribution was. To start with, my name is Bhavesh. My role in this project was as a Scrum Master, and I developed this feature of auction core services. So I owned the auction core services, which was the heart of the distribution auction system. My responsibility was to design and implement the core auction logic, including auction creation, bid validation, bid placement, and winner determination. All client requests go through this service using REST API using the JWT authentication. From a distributed system perspective, my main focus was consistency and concurrency control to prevent race condition. I also implemented a single writer model for auction, meaning only one service instance can update auction, which prevents duplicate winners. Overall, my service demonstrates strong consistency, transactional integrity with safe access. That's for me, and now other person will continue.
Let me take you to the feature of notification and event service. I was responsible for the notification and event service, which is built using an event-driven architecture with Kappa. This service listens to auction events such as bid place, outbid, auction ending, and soon, and auction won. Instead of tightly coupling services, we polished these services to Kafka and consume them asynchronously. I implemented email notification using NodeMailer and also stored in-app notifications in MongoDB, ensuring users are always informed even if they are offline. Kappa provides durability and replayability, meaning no events are lost even if a service temporarily goes down. This service demonstrates loose coupling, fault tolerance, and asynchronous communication, which are core principles of distributed systems.
Hi, my name is Prabsharan Randhawa. I worked as a DevOps and backend developer. I worked on the scheduler and leader election services, which handles automated auction lifecycle management. My service is responsible for starting auctions, closing them at the correct time, and triggering final warning winner logic. Since this is a distributed system, multiple scheduler instance may be running. To prevent multiple nodes from closing the same auction, I implemented Redis-based leader election with heartbeat monitoring. At any time, only one scheduler node is elected as the leader and allowed to process auction courses. If the leader fails, another node automatically takes over, ensuring high availability and fault tolerance. This component highlights coordination, leader election, and failover, which are advanced distributed system concepts.
Hi, my name is Ankush, and I worked as a front-end developer in the project. So I basically worked on the React front-end application, which acts as the user interface for the distributed system. I also implemented a live auction feed, auction search and filtering, auction detail pages, and real-time bid placement. The front end communicates with the backend services using REST APIs and receives live updates via WebSockets. I also integrated the real-time bid history updates, user dashboards, and responsive UI using Tailwind CSS. And from a distributed system perspective, the front end demonstrates how a client interacts with the multiple distributed backend services transparently without needing to know about the system's internal complexity. And at the last, the UI proves that our distributed architecture works seamlessly from a user's point of view.
Yeah, so together each component maps directly to a distributed system concept such as scalability, fault tolerance, consistency, concurrency, and real-time communication, making our system both technically sound and practically demonstrable as well. So yeah, that was our presentation for Group 4. And yeah, that's it. Thank you.
Thank you, guys.